Hello everyone. Believe we are waiting for others to join, so let's wait. Uh, Meanwhile, I'll confirm my connection to my SQL database quickly. I think my IP has changed once more. Okay, not at all. Let me go back to EC2. Hi
Hi
Rohi.
Sudha, good
Hi
evening.
Mugdha.
Hi all.
Again, my public IP address, of course, seems to have changed. So let me just quickly fix this and then we can start. Meanwhile, any queries for related to what we have done until yesterday?
No, Sudha.
So let me just add Sarangs. And where is the security group, man? Yeah. Should have done this earlier. Sorry for this. I'll do this from the next time before we join my IP. Save. Now this should work. Let's see. Yeah, it has worked. So let me go back in here. Okay, I hope you can see my screen. So let's not waste more time and let's go ahead. So let me just quickly log in to my MySQL instance. Yeah, and anybody wondering how I got the command so quickly? That is Control R. That's a quick shortcut on Windows. In if you are using the same client as me, I'm using the PuTTY client. So if you do a Control R and then start typing the command that you believe you have fired earlier, like I had fired MySQL command, right? So if you just start typing, then it gives you the relevant history or items from the history. Right? Okay, so let's use what was our database. Let me do a show databases. So use classroom, and here let me see show tables, and this is the case. So that is one more option which I wanted to show you, which is something like this. If you would like to directly go ahead with the database, then this option should work. Let's see. Yeah, so if I do a show tables now, as you can see, using that -a option from the command line, I've directly logged on to the classroom schema, right? So that's a quick way to save some time. That's all. It's nothing more that we are adding over here. But let's go ahead and let me try to add more data. Let me see what data I have. Select star from course. So I have 4 courses. Select star from enrolled. I don't think I have any data yet. That's correct. And select star from students. Okay, so I have 3 students. I have 4 courses. It's not good. Maybe I can have some more combinations. Well, that's fine. That's fine. Not an issue. So let me just do the insertion in now in the enrolled table as well. So let me just describe it. So I can write both ways. I can write described enrolled, or I can write DESC enrolled. Okay, both mean the same, right? These are just quick shortcuts. Now, enrolled has 3 columns. Let me just insert some values in enrolled. Insert into enrolled, and then I'm going to say values. The first will be the SID. So student ID, let's say 53666. That belongs to Rohi. Let's say he is enrolled, let's say, in course CID 1. So that's course ID, not the actual CID. So course ID 1 is database system. So I'll type 1 over here, and grade, I'll give him a grade of A. Okay, so that's the first row. The second row, maybe let's say the second student is Sarang. So 53688, 53688. That's he is also enrolled in course 1. He is also enrolled in, let's say, course 2, and his grade is B in course 2. Course 2 is what? Course 2 is, let's say, data science. And let's enter one more row. This will be for me. So I'm also 53655 is my ID, right? Let me quickly check. Yeah, 53655. And I am enrolled in, let's say, I am enrolled into the data structures course. So course ID 3, and my rating is very bad. It's C, right? So this is how we have it here. Let's enter one more value into students table, but let's just quickly check select star from enroll to see if the data is there already. It's there, as I said explicitly, the data is committed in the DB, so no problem, right? So uh, now that we have this data, let's try to play around with it, but let's do a describe on student, because I would just like to enter one more value intentionally. I'm going to add a value relevant to, let's say, Mugdha in this case. Not because our value is not added over here, but also because of the fact that I'm not going to put any data in the enrolled table, right, with respect to any courses that Mugdha is already enrolled into. So in our hypothetical world of this college, of this students group, we are not going to enroll Mugdha in any course, right? We are not going to enroll her in any course. And that's going to create some scenarios of writing queries at a later stage, right? So let me just do this. So insert into students, okay, value something. And I'm going to say that something value is, let's say, 53644. So this is Mugdha, okay. And let's say her user ID is MCSE at the rate. She's from, let's say, electronics and computer science department, so MCC, or I can say at the rate ECE. So that's her login. Age, let's say 26, and GPA, I don't know, 3.74. Yeah. So I've just entered one more value. Let's do a select star from students, right? So I have 4 students, right? I have from courses, sorry, course, okay, and I select star from enrolled. I have 4 entries, okay, in enrolled. So yesterday we were going through the aggregation functions. So let's just continue with the aggregation functions a bit more, and then we are going to look into, let's say, something else. Okay, so why I would like to go ahead with aggregation functions one more is that I would just like to do some, let's say, filtering options, which we have not done yesterday, right? Let's just try to look into that. Example, I would like to know, let's say, in this enrolled table, you can clearly see there are people like, let's say, students like Sarang who are enrolled into multiple courses, right? So I would just like to select, okay, let's say, all the records from enrolled, okay, um, where uh, uh, or I just want to know details from this enroll table where people have a grade equal to A, right? So that I can do using a where clause. Okay, where this clause is where I'm going to filter my data. So where my column is equal to some value, right? So if I do this, then I get only those rows in the output where I have that value in grid. Okay, so grade column is scanned, it looks only for those values and I get it. Why is this important? Is because this seems very simple, but combined with regular expressions, this is one of the most common query you will use along with or without using aggregate functions, with or without. Okay, with or without aggregate functions, you are going to use this, and it's really going to help understand the data. When we have a lot of data, this is one of the ways in which we can filter the data and understand the data. Right? Example given. One quick thing which usually we do. Another example is, let's say I would like to know how many distinct types of grades I have. So this query ideally comes before the previous query. Okay, my previous query was this. Let's start from enroll where grade is A. But let's say if I don't know how many grades or distinct grades are there, right? Maybe I'm not yet a subject matter expert. Okay, maybe some of you are the data entry user. So I'm not really expert in this. Let's try to understand what is going on. So select distinct grade from enrolled. A command like this, okay, is going to tell me that there are three distinct values. So this output is similar to the set concept which we saw in Python, right? So in sets, whenever we used to print sets, it is to give us the unique values. That's the same thing that we are doing. In this case, what we are doing is we are using something which is a keyword. And this is very important to understand what is the difference here. So a keyword is never having any enclosures. Okay, so there are no enclosures with respect to a keyword. Okay, the star is an identifier. Okay, this is an identifier. Okay, the star simply means I want everything. Okay, this is also a part of the syntax. Okay, this is also a nomenclature. This is also similar to the distinct clause in the sense how they behave, right? So these are essentially directives which are given to the database, and this is how they run the query. Usually what happens is, just for a brief overview, let's say this is any user who is trying to run a query, okay, and there's some client tool or some software from where he's running the query. So I'm going to call that C referring to client. Give me 1 minute, friends. Just give me 1 minute. Okay, so C referring to clients, and from here he's connecting to, let's say, database D, and inside the database D, he or she is firing this kind of queries, right? So the moment a query is fired from this side, let's say this is query number 1, okay, or query number 2, okay, there are some things that is happening behind the scenes that changes basis the database engine that we are using. It is not same for MySQL as compared to the Oracle DB, but usually overall the concept is the same. Okay, so the concept is, first of all, whenever you fire a query like this, like the ones that we are firing, it is checked in 2 stages. Okay, this client passes that request to the database server, and two things are checked. One is called the syntax, and one is called the semantics. Okay, what is the difference between syntax and semantics? Syntax is whether this select star from enrolled where grade equal to A, this command is really correct or not. Example given, are we really supposed to write an SQL command in this way or not, right? Are we really supposed to use a command like this where we have select clause, from clause, where clause, and so on and so forth? That's the first thing it checks. If there is anything wrong, and it is very smart to check that, okay, irrespective of howsoever components you have in your queries, it checks those, and it checks whether I've used the right thing or not. If I've done any typo, obviously it's going to give me an error. And how it identifies that is by means of, let's say you have done an error, and that text, the command that I've entered does not match what knowledge I have. So that's the database is going to say you have a semantic, or you have a syntactic problem. Sorry. So you have a syntactic problem. What is a semantic problem? Semantic problem is where you are trying to access this table, right? Enrolled is your table, and you are putting a filter on a column called grid, and you are putting a value which is this, right? And obviously, during runtime, if the query or the database is going to validate each and every value that you have passed, the query is going to take a lot of time. So that's why what it checks is this too. It checks the combination of table and columns. From where I've already told you in MySQL, for example, there is a schema called sys. So inside the sys schema, you already have all the metadata related to all the tables. So obviously, there will be a table, okay, inside the sys schema, which is going to tell you, or which is going to tell the database that, okay, there is a table called T where there are columns called C1, C2, C3 until Cn, right? So that is known as the semantic check. So syntactic check is whether your command is correct. Semantic check is whether the components used inside the command is correct or not, right? With respect to the metadata of the table, with respect to the functional side of things, right? So that's just I wanted to clarify. This is different for the different databases, right? But once these two checks are performed and they are passed, let's say they are green, okay? So let's say these two checks are passed and they are green, then it is submitted over here. And what happens inside this DB is that there is almost always in any database there is an execution engine. Okay, there is a software, there is a program which executes your query. It is going to execute it basis something which is known as a plan. Okay, or you can also call it a query plan. Okay, you can also call it an execution plan. In many databases like Oracle, it's called explain plan and so on. Okay, so explain plan is not actually the name. It's actually one of the command line tools which we use into Oracle to look at whether our queries are really efficient or not. So when we are doing this kind of, let's say, data engineering, we need to know these things because there's always an execution engine which is going to run the query. And this execution engine, how is it going to know the correct way in which the query has to be run? Okay, that information is got from the metadata. Okay, so you have to always be in sync with your DBA. Sorry, friends, I think I was just disconnected for a moment. Let me just come back and let me explain once more. I hope you can hear me now. Hello?
Yes.
Yeah.
Yeah.
So
Now,
the database engine was there. What I was saying is there is a syntactic and semantic check. And after that, inside the database, there is an execution engine. And that execution engine, what it does is that it's going to execute the query basis the metadata. Okay, so the metadata which was there in the sys schema. Okay, so obviously you can understand that sys schema and the metadata within that schema is really important for your queries to be efficient. Okay, as a developer, as a data engineer, maybe this is not the first priority for us, but we need to be very careful. We have to work alongside our DBAs and we have to ensure that we really have the right amount of, let's say, metadata which is collected inside the database. If there is any stale or outdated kind of, let's say, metadata, then it has to be cleaned or updated or cleared from time to time. Okay, so that's really important. It's important for us because when we play with big data sets and if our queries are not running well, then obviously my data engineering pipeline is not efficient. If my data engineering or ETL pipeline is not efficient, then how will my machine learning or data analysis pipeline be efficient? Because ultimately, first of all, I have to gather and prepare the data. Then that gets passed as an input to the next stage, right? I hope you all can still hear me, right? Because I'm getting a warning from Zoom that my internet connection is unstable. I don't know why.
yeah, yeah.
Yes, Udaya.
Yeah. Okay.
Audible.
Yes, Bhaumik, I can at least.
Okay. Okay. So basically, what finally we are going to do after learning all these things is that we are going to have a data collection or a data engineering pipeline. This data engineering pipeline is going to have the ETL. Okay, so the ETL layer will be here only, and then we are going to have, let's say, the data analysis as well as the machine learning pipeline, which we usually run using the Jupyter Notebook. So this both of these things can be combined as part of Jupyter Notebook. As a later stage, we'll also see this, right? We are going to connect from my, let's say, Jupyter Notebook. I'll install something maybe on the same host as this MySQL server just to save time. I'll install Anaconda on that host and we can run Jupyter Notebook from there, which can connect directly to this MySQL database. And we can do all of these queries, right, within our notebooks, right? Within our notebooks, I can do that. And finally, the most interesting thing, when I'm done with all my analysis and I'm ready with my sample, I can actually directly read that sample as a data frame. So that's really going to be very interesting. But that is under the assumption that I, being a data scientist, I already have access to the database to perform these tasks. If that's not the case, then I'll have to wait for some data engineer to provide me with the CSV files every day, right? And then I'll have to do these things. right? So let's keep that in mind. Let's not forget that. But let's continue with the queries that we were writing. Now, the power of where clause, where does it come into picture? The power of where clause comes here. Let's say I have select star from students. Okay, so I have these 4 students over here, and I would like to know which of these students have names starting with S. Okay, so what I can do, select star from students where name like. Okay, this is yet another operator that I can use, and now I'm going to use regular expressions. So I want names starting with S, and then there can be anything. So that anything is represented by means of a percentage sign, right? So this is a very quick or very silly kind of a regular expression. The most basic form of, let's say, regular expression. You can find a lot if you look on the internet on let's say resources and websites which you already have. You can look for even more. I'm sure the MySQL and Oracle database documentation also has a lot of entries. So more and more can be found out in this one. Most easy one that we use is kind of this percentage sign that we will most commonly use. Okay, that is the most common thing that we are going to use, right? So the percentage sign that now I've used should give me the output, but let's see the problem that we are going to face. If I press enter, right, I see that MySQL was smart enough, okay, to convert, my name into such a way, my name values inside the name column in such a way that it was able to match uppercase character as well as lowercase character. Why I say this is because this S percentage means my name can be Saransh, it can be Suddhasattva, it can be anything else. Anything else starting with the letter S. Now, in these 2 rows, what I'm saying is the first letter for Saransh's name is S, while that for my name is small s. Right? Irrespective of that, MySQL is smart enough to convert that, right? But this may not be the case with all the databases. All the databases will not be so lenient. So what you usually do is that, I think I've lost the connection again. Are you able to hear? Yeah, I think I'm back now. So yes, yeah. So there is some
Yes,
problem.
Sada.
Definitely there is some problem with my connection today, because I am not able to fire command. Okay. Is this a problem on my laptop or is this a connection problem? Give me 1 minute. Let me just see what problem this is. I don't think this should be a problem with. Should be a problem with. Yeah, I think it should work fine now. So what I'm doing over here is, oh, let's duplicate session. Let me open another session. Let me open another session and see. Yeah. Okay. So I think I'm back now. So this is the previous query that I fired. As I said, the best way to do this is, if you look at this function that I'm using now, I'm going to use a lower function here, and then I'm going to say it is S, or even better, I'm going to use this as capital, and I'm going to call this as upper. Okay, so this is a really good way to present the output, right? Why? Because now I'm not taking any risk. Now my query that I've written over here is independent of whether I'm running a MySQL or an Oracle DB. Okay, so the query is now going to run everywhere. But do I really need all the columns? Maybe not. So what if I try to select the name, only the name, and then let's say the age and the GPA. Okay, so if I be selective, I can do it like this. But then again, I have a problem. Let's say I'm just trying to play around here. Okay, I'm just playing around with queries so that I can tell you the various different functions and options that we can use. Okay, so let's say the first field is name. I would just like to convert it into uppercase because I have some problem with uppercase and lowercase. So I'm just going to convert this like this. So I can convert it into uppercase like this. I can also give it an alias. This thing that I've used over here, right, as name. Okay, this name text that I've used, this is an alias. Okay, this is a column alias. As you can see, it is an alias used for the column name. If I don't use that, it's going to print the column name as upper name, right? So just to avoid that, we are doing this. Okay, then what I can do, let's say, um, uh, the other thing that I can do is that let me also order this data, also sort this data based on the age of the student. So I'll say order by age. So by default, what it has done is, because I've not specified in which direction that order must fall in, whether it's going to be an ascending order, whether it's going to be a descending order, I have not specified. By default, it's always ascending. Now you see the list has reversed. So my age is less than that of Arang's in so in that case, in this table, that's the case. So in that way, the ordering is done basis the age, right? So if I would like to do this in the reverse order, I just have to add the descending keyword, which is DESC at the end, and it's going to do it in the reverse order. Okay. I can also specify the ascending keyword by means of ASC. Okay, I don't have to do that mandatorily. That ASC keyword is actually optional because by default it is ASC. You saw that already, right? The same thing applies to GPA and all these things as well, right? Okay. Now, let's just look into a few more functions. I hope this was clear until this, and let's just look into the fact that uh, where or how we can use multiple aggregates. Example given, I would like to know, let's say I would just type it over here, get the count of my students, okay, from my database and their, okay, average GPA, okay, GPA. Okay, so I just want to know what is the count of students with average GPA. What I mean by that is, let's say one student has an average GPA of 3, two students have an average GPA of 4, and so on. I have a very small kind of a data set, so maybe this example may not prove very useful, but let's see how we can do that. So I need an average of GPA, which I can name as GPA average. Okay, and then I need the count of students, so I can do a count of SID, which is my student ID, as count of students from students. Okay, if I do that, I see there are 4 students with an average GPA of 3.66. Right now, what happens if I increase the number of students in the list? Let me just select star from students. Let's try these things. Will be clear, right? So insert into students values. I'm just going to enter one more student in this list. So 53633, right? This is the next student. I will give him a name. Let's say Anna. Sorry, I have to put this in single quotes. Then Anna's ID is Anna underscore CSE at the rate CS 2020. Okay. And then her age is, let's say, 26, and her GPA is 4.8. Okay. She's a really, really good student. Okay. This GPA of 4.8 is really good. Now, what happens if I do an average of this? Okay. You see what it is doing? It is simply taking an average of the entire data. By default, it's going to take all the aggregation functions. It's a very important point to note. By default, all aggregation functions work on the entire set of data unless you put some where filters. So that's exactly what I'm going to do. Now, what is the output of above query? Okay, what is the average GPA? So what is the average GPA for students with name, okay, starting or maybe I'll use a different example. Name we have already done, right? So average GPA for students who are less or equal to 25 years of age. Okay, so what I'm going to do, the same query I'm going to fire. I'm just going to write where age is less than or equal to, age is less than or equal to the value 25. Right, it is giving me some error, and the reason why that is giving me an error is because I have these two semicolons. So ideally I should have only one. Okay, so the moment I do this, you see now the number has changed, because what I'm doing now is that count of students where age is less than equal to 25 is 2. You see here I have two students whose age is 25, me and Rohi, we are 25-year-old. Okay, and then our average GPA is 3.5 plus 3.5 divided by 2, ultimately, obviously 3.5. What if this is not the case? So let's say age is greater than 25. Okay, then I get 3 students with an average GPA 4.14. Right? So in total, we have we have how many students? 5 students, right? 2 students whose age is less than or equal to 25, average GPA 3.5, age greater than 25, average GPA 4.14. We have 3 students like this, right? So this is the way we can play around with the data. Aggregations make a really good value when we combine them with the where clauses, but that's not to say that it's only with the combination of where clauses that they're going to work. Okay, even without the where clauses they're going to work. But what if, well, let's add a twist here. What if, I would also like to know, I don't have such a column over here. Okay, I don't have such a column over here. Maybe we are going to do that when we look at other tables. Maybe I can look into. Let me just try to formulate the example, because I think that's, yes, I can do that with enrolled table. Let's take the enrolled table. Select star from enrolled, and I would like to see what is the let's say select is a very bad kind of a query. Okay, select count. Select count, just a very dummy query. Count of let's say course ID, or let's say distinct courses. Okay, as count or number of distinct courses from enrolled, where, okay, where student ID or a grade, okay, grade is equal to A. Okay, so I have only one, okay, distinct course for which I've got grade as A. Right now, I would like to, or maybe I'm going to change this query now, and I'm going to call this as where student ID, okay, student ID is greater than or equal to 53, 56, 53633. Right, I get 3 output as 3 distinct course IDs where the student ID is greater than 53633. Okay, or maybe what I can do is that this is becoming very obvious, so I'm going to call it 55. Okay, so now greater than or equal to, maybe I'll change it to greater than. Okay, you will come to know why I'm doing all these changes. I'm just playing around with this query, and now what I'm going to do is that I'm going to show you one very important thing. Now I would like to select the grade column as well. And the reason why I'm doing this is because now in my select list I have a combination of 2 kinds of columns. Okay, one column which is an aggregate, which is the count of distinct course ID, and one column which is not an aggregate, which is just a direct pull, which is the grade column, right? So grade column is a direct column. Count of distinct course ID as number of distinct courses is an aggregate column. Is that query going to run or no? The answer is no. It's not going to run. It is not going to run because it is going to complain me that you are not grouping your output. You have to mandatorily group your output, okay, in or within the query, in form of the query, if you are pulling up aggregated as well as non-aggregated fields at once. Okay, if you're going to do that, or if you would like to do that, you are going to use a clause called group by. Group by grade. Why group by grade? Group by the non-aggregate field that you have pulled. So non-aggregate field over here is grade. Aggregate field is count of distinct CID. So if I do a group by grade, now there is no error and it gives me the output. Okay. If I just remove the distinct clauses and I simply say number of courses, okay, number of courses, let me just remove the distinct clause over here. It is going to tell me the non-distinct count as well. So grade A, there are 2 courses where I have grade A. Okay, grade B, I have only 1 course where I have grade B, but that does not mean that's the unique number of courses. Unique is when I will use the distinct clause, right? Now, what if I would like to order this output? In this output, you see number of courses is 2 and 1. I would like to order this in the ascending order of the number of courses, right? Then I know I can use order by. So I'm going to use order by over here. Okay, or order by number of courses. If I do that, it's going to order my output. This is one way to order. The other way is number of courses is what? NO of courses is an alias given to count CID, right? So I can also use count CID over here. Okay. Third and the most important thing to remember, if I remove order by over here and put it before group by, let's say order by number of courses and then group by, it's going to give an error. You have to mandatorily group by grade first. You have to group the output, then only you can order the output. Unless and until you have grouped it, you don't have a table, okay, that you can sort or that you can order. Please note this. It does not work even if I would have used order by count CID in case of order by number of courses, right? This is really very important, but these are summarization functions or aggregation functions. This will help you prepare the data, aggregate the data, so on and so forth. Okay, let's say you have a big data set and you would like to, let's say your data set consists of a lot of employees in your organization. You would like to figure out specific characteristics of those employees. Example given, for each and every employee, count the number of times they have attended trainings, right? So maybe your use case is something like this, and here you are trying to create the features. Okay, so how you are doing is you have an employee table, and you have a table where you have a lot of courses which are given, which were taken by those employees as part of the trainings, right? In our offices, we do a lot of training. So you are taking, you are maybe finally you are going to create a big data set which you are going to use to do machine learning, where you are going to do, let's say, employee ID you are going to select, name you want to select, and you want to select the features. And these features will be, one of the features is going to be the count of courses for which the students are enrolled. Rohi is asking, will this be an error in all types of DBs or only in MySQL? No, Rohi, this error that you saw over here, right? This error is going to be for any database. This error is generic. Unless and until you group, you cannot order. Okay, as simple, right? Okay, so coming back to the example, we just have 2 minutes left. So we'll just take this example and then we'll make a close and we can continue from tomorrow once more. I'll do the preparations from tomorrow a bit early so that we can cover more. I think we are a bit lagging in speed. So let's say the third feature which you want is the count of courses that an employee has taken. Maybe that's a good representative of how the employee or how much the employee is interested of learning new things. So how you do this is basically by using things like this. And one more thing that you are going to use in this case is to join these two tables. Okay, you are going to do a join operation, something that we are going to see from tomorrow. There are officially 3 kinds of joins that you can do. And in total, no, I'm sorry, there are 4 kinds of joins that you can do. Right. So we are going to look at each kind of join and we are going to see how we can do things like this. We have a different kind of a data set here, so we can find out that kind of data that matches to our data. Right. I think let's make a close here. I think the time is also up. So let's make a close here, friends. Let's meet tomorrow once more. Thank you so much. Thank you for joining.
Okay, bye everyone.
Thank
Good night.
you.
Thank
Good
you.
night.